Hello, good morning student. How are you? I hope you all are happy at home. So, what did we discuss yesterday? We discussed about strength of organic acids and bases, comparative study, and factor affecting the strength of acids and bases. In that we just started the strength of acids. We derived one of the expression of pK value. Here just remember, if pK value goes on decreasing, the acidity goes on increasing. Second important point you remember, minus I inductive effect as well as minus R inductive effect, if present in the acid, both are increasing the strength of acidity, and therefore yesterday we have seen, I think, 1, 2 or 2 application. I think one, propanonic acid is weaker than acetic acid, or acetic acid is stronger than the propanonic acid. That is the first application we have learned. Second application, formic acid is stronger than acetic acid, or acetic acid is weaker than the formic acid. Now third application we are going to discuss today. What is that? If halogen substituted acetic acids are stronger than acetic acid. Substituted halogen acids are stronger than acetic acid. Or the question may be here, the chloroacetic acid is stronger than acetic acid, or or here, or you can write here, suppose as a chloroacetic acid. Chloroacetic acid is stronger than acetic acid, or here you can call it as a explain, or how do you, in another way we can say that acetic acid is weaker than chloroacetic acid. So let us see some of the substituted halogen acids, mainly as a, for example, let us see here F, then CH2, C double bond O, OH. This is one of the structure I have drawn here. Let us see Cl, then CH2, C double bond O, OH. Then let us see another one, Br, CH2, C double bond O, then OH. Let us see another one, I, CH2, C double bond O, OH, and let me draw another structure, CS3, C double bond O, OH, which is acetic acid, right? You know that this is the name of this compound is acetic acid. Acetic acid, or the F.Y.B.Sc name of this compound is the ethanoic acid. But here What is the name of this compound? The name of this compound is a fluoroacetic acid. The name of this compound is a fluoroacetic acid. Fluoroacetic acid, right? Fluorine atom, one of the hydrogen atom, replaced by fluorine atom, and therefore that is termed as, or which is known as, fluoroacetic acid. So now you are able to give the name of this compound. This is a fluoroacetic acid. This will be the chloroacetic acid, right? This is a chloroacetic acid. Now tell me the name of this compound. Here fluoro, so we are calling it as a fluoroacetic acid. Chlorine group is there, that's why we are calling it as a chloroacetic acid. Here is a Br, means it is a bromoacetic acid. This one is bromoacetic acid, right? Now this one, there is a I means iodine, so we can call it as a iodoacetic acid. Iodoacetic acid. This is iodoacetic acid, and the last one we already given name here, which is acetic acid, right? Now fluoroacetic acid, chloroacetic acid, bromoacetic acid, and the iodoacetic acid. Now if you consider here their pK values, on the basis of their pK values, let me write some of the pK values. pK value, as we know that pK value decreases, the acidity goes on increasing. As we know that yesterday we calculated the pK value of for acetic acid at 25 degrees centigrade, means at room temperature, the value found near about pK value. pK stand for, K is a dissociation constant for acid K, and therefore it is, I think, 4.76. So that is the pK value of this for this acetic acid. Now fluoroacetic acid, roughly I am going, and no need to remember that one, but at least you should, this is what we are saying, that substituted halogen acids are stronger than acetic acid. It means that they must be less than this one. So the fluoroacetic acid having as a pK value, I think 2.66 approximate 2.66, and it having, I think, 2.76 something, and it having bromo 2.88, and this having 3.16. That is a approximate values I am producing here. I am giving here exact value you can find out from the book, but the main point here, remember what I am trying to explain, why that chloroacetic acid, this is a chloroacetic. If you compare between these two only, chloroacetic acid is stronger than the acetic acid. We know the pK value. pK value is a 4.76, and the chloroacetic acid has a pK value 2.76. And what is our general rule? Tell us that the general rule said that the pK value decreases, acidity goes on increasing, and therefore they look at here, the pK value is a less here, and here is a greater, and therefore chloroacetic acid is a stronger than this one. But if you, this is all about why this one is a, if you compare between these substituted halogens, fluorine atom is the strongest than this one. Why this so? The acetic, if you move from left hand side to the right hand side, the acidity goes on decreasing, goes on decreasing. Why this so? Because there is a it depend upon the electronegativity. As we know that these are the halogen family member. Halogen family member, if you remember, you might be knowing the modern long form of the periodic table. In the long form of the periodic table, there are vertical 18 groups, 18 columns are there, and they are called as a group. So in a 17 group is known as halogen family member. Halogen family members, from top to bottom, we know that there is a fluorine, chlorine, bromine, iodine, and astatine. Astatine is a radioactive, so don't consider here, but these are the atom: fluorine, chlorine, bromine, and iodine, right? Now if you electronegativity means what? It is a power of attraction of electron toward itself, or it is a measure of power of attraction of the electron density toward itself. So that is called as the electronegativity. It is one of the important property of the element, physical property of the element. As we go across the period, the electronegativity goes on increasing, and therefore fluorine is the most electronegative element present in the long form of the periodic table. Remember, across the period goes on increasing. It is these halogen family members are present in the 17 group. 18 is a 0 group element, or which is termed as a noble gas element, and that noble gas element, they do not show the electronegativity. They are the inert gas element. They do not take part in the reaction. So up to the fluorine only electronegativity you have to consider. As we are moving from left hand side across the periodic table, the electronegativity goes on increasing. As we move from top to bottom, what will happen? The electronegativity goes on increasing or decreasing? It goes on decreasing, and hence the fluorine is the highest electronegative element in the long form of the periodic table, and therefore reactivity order is like this. And as we know that halogen group are the most halogen group are the having ability to pull the electron toward itself, and the adjacent carbon atom becomes as a electropositive in nature, and therefore it exerts as a minus I inductive effect. And as we know that minus I inductive effect increases the acidity, and therefore it also shows as a minus I inductive effect. Here also as a minus I inductive effect. Here also as a minus I inductive effect, but here methyl group exerts the plus I inductive effect. Plus I inductive effect decreases the acidity, whereas minus I inductive effect increases the acidity. And due to this reason, substituted halogen acids are stronger than acetic acid. Understood this one? Now chloroacetic acid is stronger than acetic acid. At that moment you must remember, you must draw the structure of this one only, chloroacetic acid, and second one is acetic acid, and after that you dissociate it, and after the dissociation we are going to get CH3, C double bond O minus charge, here positive charge, plus I effect, and here H plus is a proton. Now this is the acetate ion. Acetate ion is destabilized due to the plus I effect, and therefore acidity is therefore this acetic acid is a weaker acid as compared to the chloroacetic acid. In a chloroacetic acid, after the dissociation, what do you get here? Cl, then CH2, C double bond O minus, and H plus. Here, due to the chlorine atom pulling the electron density from this carbon atom, therefore it shows minus I inductive effect. When it shows as a minus I inductive effect, the acidity goes on increasing. according to our general rule, and therefore this minus I inductive effect will stabilize the conjugate base. And yesterday we have seen what are the strength which stabilize which affect the strength of acidity. First one is a strength of that HA bond, and second one is the stability of the conjugate base. This conjugate base is well stabilized due to the inductive effect, minus I inductive effect, and therefore this chloroacetic acid is stronger than the acetic acid. This is the 3 or 4 application here we have covered. Now let us, and why this one is the strongest one, that is depend upon the electronegativity. If the electronegativity of fluorine atom is a greater, so magnitude of that minus I inductive effect is the highest in this fluoroacetic acid, whereas the magnitude of minus I inductive effect is least in the iodoacetic acid, and therefore fluoroacetic acid is the strongest acid among these all substituted. So this is the order of acidity order of this compound. Now let us move on to the next application, maybe as a this is fifth. Next application will be this one. 2 application we already learned here. Now third or fourth application we can call it here. Fourth application maybe let us take here. Fourth application, fourth one. Now fourth application. So here what is that? Suppose as a trichloroacetic acid is a stronger than acetic acid. Trichloroacetic acid is stronger than acetic acid. Explain, right? Or in other way around, we can modify this question. Acetic acid is weaker than trichloroacetic acid. Explain. So how do you explain this? The answer of this question. What is our first things to do? First things while answering, so you must draw the structure of the organic compound trichloroacetic acid, and you might be knowing 100% of the student are knowing the structure of acetic acid, but trichloroacetic acid maybe, as per as my opinion, 95% student may be knowing the structure of trichloroacetic. Let us see as a acetic acid structure. Everybody knows this is acetic acid. Structure of acetic acid is this one, right? And after the dissociation, acidity is measured. It depend upon the extent of dissociation of the H plus ion. Number of H plus ion produced, stronger is the acid. And after the dissociation, whatever conjugate base is formed, that conjugate base, whether it is stabilized by inductive effect or resonance effect, minus I inductive effect or minus R inductive effect, then and then they get stabilized. But if plus I inductive effect and the plus R inductive plus R resonance effects are present, they get destabilized due to that, and they get they shows as a list. Now let us see here how to represent this dissociation reaction. As we know that the bond is cleaving or bond is breaking from here, fission takes place heterolytically, and we are going to get here CH3, C double bond O, then O minus and the H plus. That's it, right? Once you draw the structure of acetic acid, acetic acid, this one, and this is a conjugate base, or we can call it as a acetate ion, acetate ion, which is a conjugate base ion, conjugate base, and this conjugate base is destabilized due to the plus I inductive effect. Here you can write destabilize due to plus I effect, right? And plus I effect, and therefore there is a difficulty for dissociation of OH due to this methyl group is the electron donating group, and that shows as a destabilization due to the plus I inductive. That's it. Now next one, the structure of trichloroacetic acid. What is the structure of trichloroacetic acid? Remember, here are 3 hydrogen atoms are there. If all the 3 hydrogen atom replaced by chlorine atom, that becomes as a trichloroacetic acid. And most of the student, specifically you student, I am saying most of the student, not all, few of the student are making as a mistake. What they are showing? They are showing this one, right? This is Cl, not this one. They are showing here Cl, then C double bond O, Cl, then maybe as a Cl, 3 Cl attached, then OH, right? This type of they are showing some of the student. 3 or 1, 2, 3. This is a acetic acid functional group. This is not the correct structure. Remember, carbon has a 4 bond. If you look at here, 1, 2, 3, 4, 5, and 6. Carbon never shows as a more than 4 bonds. Always remember, those are studying as organic chemist. Now 3 hydrogen atom you can replace like this, 3 hydrogen atom, then C double bond O. It is our functional group acetic acid. We can write this way. Carbonyl group you can write above, or you can write below, or you can write just as a COOH, doesn't matter, or you can write like the C double bond OH. It is a functional group, and as we know that functional group means site of reaction where the changes are occur is known as this one. Now after the dissociation, what will happen? This bond is going to cleave here, and you are going to get here Cl, then C double bond O, O minus, and the H plus, right? Now look at, there are 3 chlorine atom here. Now chlorine atom, they are the electron withdrawing group. They withdraw the electron from this carbon atom, and therefore they exerts, or they shows minus I inductive effect. And minus I, there are 3 chlorine atoms are there, and the magnitude of that minus I inductive effect is increased over there, and due to that reason this conjugate base, this is a conjugate base, and this conjugate base is well stabilized due to minus I effect, and therefore trichloroacetic acid is stronger than acetic acid. So this is the simplest example or the answer to this question. Trichloroacetic acid is stronger than the acetic acid. You have to draw the structure of acetic acid as well as trichloroacetic acid, show the dissociation, because when it producing as a H plus, this is nothing but as a proton, right? Number of proton produced, that decided the strength of whether it is a stronger or the weaker acid, and that is depending upon, here is a plus I inductive effect, here is a minus I inductive effect. One general rule, remember, minus I inductive effect increases the basicity, whereas plus I inductive effect decreases the basicity, and that's why trichloroacetic acid is stronger than acetic acid. I think with this, let us stop today here. Remaining we will see the next lecture. Thank you. Have a nice day.